All right, what we're going to do is we're going to take a look at how to calculate the area of a triangle. Now, what we've already learned is how to calculate the area of a parallelogram or any kind of a rectangle, the shape. So this is an example of a parallelogram that we're looking at here. And let's say we've used grid paper, and we're just going to say for scalability that each one of these squares is 1 meter by 1 meter. Okay? So therefore, one of these squares is 1 meter squared. All right, so what we do is we take a measurement on the one side. So we say 1, 2, 3, 4, 5. This is 5 meters by 1, 2, 3, 4, by 5 meters. So we got ourselves a perfect square here. And since we know that area equals base times height, we can simply say that all we have to do to calculate that is to say, well, it's obviously 5 times 5. And our area is going to be 25 meters squared. So far, so good, no problem. Well, let's take a look at why this is important when we are trying to calculate and understand why it is we calculate the area of a triangle the way we do. All right, let's take a look at this other rectangle here. So we've got dimensions on here, 6 meters in height and 7 meter base on this rectangle. So we already can simply calculate out that this would be, this would simply be 6 times 7, and therefore the area would be 42 meters squared. All right. But the reality of it is if I were to take a look at this rectangle and I were to actually split it down the middle, like so, I've actually created for myself 2 triangles. And so by cutting that rectangle in half, we've actually created 2 triangles. So to calculate the area of one of those triangles, all we would have to do is take this total here, the area, and divide it in half. So because of that, we can say that area of a triangle is base times height divided by 2, split in half. So in this case, we know that the area would be 6 times 7 divided by 2, which equals 42 divided by 2, which equals 21 meters squared. Let's take another look at another example to clarify. All right, let's take a look at this triangle here. Now, going back to what we've already learned, we know that the formula that we're going to be using here is going to be base times height divided by 2. And just to clarify, the reason we do that is because we know that a triangle is half of a parallelogram. So what I've got here is I've got an example of a triangle. And just to prove that it is in fact half a parallelogram, I'm actually going to create one here. So if I just take this and I were to say copy it out and I were to make 2 of them, okay, and then if I took one and I just kind of rotated it slightly and took the other one and rotated it slightly, and I were to put the 2 of them together, you can see clearly that they are in fact have created a parallelogram. Okay, so this here, this whole thing would be would be a parallelogram. So we're going to take a look now and actually calculate out and take a look at what some of the measurements are. All right, so let's say we decided we wanted to do a measurement here, and we're going to say that this is 10 centimeters base. So let's plug that into our formula so far. So we've got a base of 10 centimeters. We've got to times that by our height, but we got to figure out how we're actually going to measure height. Well, in order to measure height, we have to make sure that we're taking our highest point, which would be right up here, and measuring it to our base. So what we're going to do is we're actually just going to create a little right angle here to help us measure, and then what we would do is we'd actually take a measurement. So let's say, for example, this is 7 centimeters high. Now obviously these aren't accurate measurements, but we're just going to hypothetically use them here. So we take that measurement right there from that right angle. The biggest mistake that students make is they measure this side. When they're actually doing measurements, they would actually measure a side, and that is incorrect. Okay, what you want to do is you literally want to create a right angle here and measure your highest point at right angles to your base. And that's what we've done over here. So now what we're going to do is we're going to take that and say, well, our height is 7 centimeters, and to finish off our formula, we have to divide that by 2. So therefore, what we can say is that 70 divided by 2 is going to give us our area, and 70 divided by 2 is 35, and in this case we're dealing with centimeters, and we need to make sure that we indicate that it is in fact 35 centimeters squared. That squared is extraordinarily important because if you're just saying it's 35 centimeters, well, now you're not referring to surface area, you're referring to distance. So you have to make sure that you're very specific by putting that in there. Okay, so let's take a look at this triangle. Obviously, we're just going to be making up some measurements here, but if we were to actually measure this, we would have to make sure that our measurements were in fact accurate. Now, we've already measured the base here, which is the 5 meters, so we can say that area equals 5 times the height, and we haven't then divided by 2. So we haven't actually determined that yet. Like we said, the big mistake is that students will measure this area here to say that that's the height. That is not the height. It's not at right angles. Okay, this here would be classified as the height because it is at right angles to the base. Okay, and it's at its highest point. So let's say this particular one was 8 meters high. All right, well, we're just going to plug that information in. 5 times 8 is 40. Divided by 2, we can say that the area in this case is going to be 20 meters squared. All right, so we got ourselves a little problem here because we know the base, which is 5 meters, but we don't know the height yet, and we know that the area is 20 meters squared. So if you remember back to the previous videos when we talked about working in reverse, let's go back to a very simple concept here. If we had 2 times 3 and that equals 6, we know that division is the opposite of multiplication, so we could say 6 divided by 3 is equal to 2, and we can flip it around. Well, we can do the exact same things with our formulas in order to determine missing measurements. So what we've got here so far is we know that when we, to get our area, we know that we have to do base times height, and then we have to divide it by 2 in order to do that. But what we already know is that the height, or the area of this is 20 meters squared. So since we've already divided by 2, what we need to do is we first need to work in reverse. So what we can say is that we're going to take the current area, we are going to now do the reverse of that, which is multiply it by 2, and then we are going to divide it by the base, which is 5 meters. Whoops. Which is 5 meters. Well, let's take a look at that and see what happens. All right, working again in reverse. Since we already know in order to get this, we had to divide by 2, well, we're going to have to do the opposite of that in order to find out our height. So what we can say is that our height is equal to our area times 2 divided by our base. We're working in reverse now. So in this case, we can say height is equal to 20 times 2 divided by 5. And in this case, 20 times 2 is 40. And when you divide that by 5, we end up with 8. Our height here is in fact 8 meters.